Hi everyone and welcome back to my desk. Today we're going to be working on an interesting project that should hopefully improve how I work on electronics. In fact, what I have here is a small optical microscope that is handheld. So you place this over the electronics that you see, and through that eyepiece you're going to look at chips to identify numbers and stuff. And over here I have a web camera that is being salvaged out of an old laptop, and I've connected that to a lead from a damaged camera. And the idea is that we're gonna combine the two, plus we're gonna add a rechargeable battery so we can have digital microscope that we can connect to the computer, and I can then use it to add the chip numbers and anything that I'm working on, any details to the videos that I make. And before we start with any work, I want to thank today's sponsor, which is Altium 365. Altium 365 revolutionized electronic design, making collaboration seamless and efficient. With this platform, all of your designs, procurement, and manufacturing needs are integrated into one centralized space. Work effortlessly with your team in real time from any device without any additional tools. Experience easy tracking of design changes and manage your components smoothly. Its browser-based interactive interface with global sharing and robust data management ensures your projects are secure and innovative. Click in the link in the description to get your free Altium 365 workspace and elevate your design process. Okay, so there are several issues with using this microscope because, first of all, I need to have my eye really close to this eyepiece, and this needs to be on top of the PCB that we are looking at. So I'll need to get down, and it gets really uncomfortable to look at small pieces. I can bring this to my eye, but usually if I'm working on a large electronic, I need to bend down and look through the eyepiece. Second, this has a light, so it has a light on bottom to illuminate whatever we're reading, and that is powered from three 1.5 button cells. But when the original ones got empty, I replaced them with larger ones because I couldn't find the size that this was using. So it's using large but very thin batteries, and the idea is that we're going to replace this with the lithium cell, so hopefully we can last a lot longer, and we will not need to find those button cells anymore. And the idea with the camera, this I was using for my son when the COVID thing was happening. So there was a shortage, I couldn't find a webcam, and I extracted this from a broken laptop. So the idea is that I'm gonna make some holder to have that camera at a certain distance, and we can then look through the eyepiece through the camera on the computer on a much larger screen and have it more ergonomic and more functional. So before I do any work or design anything, I want to verify, and I already did this off camera, but here I have it on camera. I want to verify that we are able to see through the microscope with the webcam, and you could see here the webcam now points upward. This is my camera that I'm recording on. So I'm recording the image as well. So I'm gonna turn this on, rotate and place the camera on top. And you could see that I'm getting some image, and if I align it just right, you could see that we are actually getting, so this is the 4056 charger chip from the battery board that we are looking at down here. Let's try and look at some other chip, and you could see, so we have the 8205A, and this is exactly what I want to achieve, to have the camera being a bit away from the lens and have it in place and aligned properly at all times. So let's try and design something in Fusion. Okay, so in Fusion I first measured this round part on the top where I want to have the attachment to be as sort of a cap, and I started by drawing that as a circle with some overlap that I can then extrude, and I'm gonna show you the steps here in the timeline. Let me finish the sketch. And from there we could extrude the part that will sit on top of the eyepiece. And then I made another one, so this one has like a small notch that will sit on top of that and capture. Then I did another sketch and I did another extrude to the holder. And if I turn on the sketch, so this is the sketch that I drew on top of there to have an enclosure for the camera, where the camera will be on the middle. And then with some few more extrudes, I came to have this. So this is like a tray that can hold the camera. And I also at the end removed a small piece where we're gonna have the connector of the camera where it's gonna sit. And with the final extrude, I removed one of the walls here at the end, so I could have the cable going on the side. So I then 3D printed this, and here is the first 3D printed part that didn't actually quite work, but I will get back to that soon. That it just snaps over the eyepiece and it even can be rotated, and that has like a good friction fit. But the first issue was that I didn't make it wide enough, so camera doesn't go in the slot as it should. It seems that it's holding the cable connector quite nice, and the camera is actually aligned properly. But when I tested this, and let me show you now how it looks from the camera. So here how it came up. It's a really difficult to align it because this PCB, you could see it's not really staying as it should, and there's quite a bad flare as well because it's sitting too far away. And when I try to focus that, I'm just always way too close to whatever I'm trying to record. I'm looking at different PCB. I'm looking at the BMS now. So I went into Fusion to make a second version of the same thing. The main difference is that I reduced the height of this circular part to just 2 millimeters, and I made the hole here a bit wider and also a bit bigger so it can accommodate the PCB better. Looking at the part now, I think I could have split this into two parts where it would require some assembly, because I printed this with some support, and you could see that on the end I didn't have the layers adhesing very well, but that should not affect the functionality. So the piece mounts correctly, and now when I add the camera, it can sit completely flat on the surface and it's properly aligned. And you could see now that the image is much better and much well aligned, and it kind of depends on the chip how well it's being read, but this is definitely a lot easier and better for my spine, that I'm able to sit upright and look at the board in what it says on the chips. We can try to look at some of the components, some of the smaller components, and we still have access to the focus adjustment. So we have the W01 chips here and 105, and we can play with the focus a bit to get a better image. Now we could also play with the zoom, because this can zoom much more. Let's try that and focus the image on some component. Okay, here we have it on the resistor, and we could look at the solder joints and look at the chips. So this one has a marking of 2L, and it's some sort of a transistor with 3 legs. What else? Let's try to look at something. If we look at the markings, so you see now they are quite enlarged, and we can try to focus the image there. And I know that it's not perfect, but at least it gives me a way to get the numbers of the chips a lot more easily than if I would bend down and look at the microscope eyepiece directly. Okay, so here is the microscope with the camera piece on top. I added a bit of electrical tape so the PCB sits flush there. I'll probably design a small cap that can go on top of that to hold it in place. But if we look at the image and we can place it over a component, and we could look at the different solder joints. I was looking at one of the, I think not the capacitors, but some of the resistors up here. So you could see on this one, let's try and adjust the focus. Okay, so now you see the other issue with the LEDs. You could see that up there seems to be soldered nicely, but the joint on the bottom is not that good. And I think that was the case with some other resistor that I now lost. In any case, we can clearly see components on the board. And now I'm gonna tackle the other problem where instead of having the coin cells here, I'm gonna add the lithium battery with the possibility to charge it. Now, I could use the 5 volts coming in from the lead, and I was thinking about doing that, but that would cause two issues. First of all, if I don't have the camera, I can still use this as its own separate microscope and still look into it without the camera attachment. And second, one of the things that I found out is that if I have the values upside down, so we have this one, for example, where we are looking at the 2L, it's a bit difficult to read because it's sideways, but we can rotate the camera and then we're gonna look at the component the right way up. Now this complicates the movement because now the reference is a bit off, but still when we are exactly at the component, then we can easily track it and see the values that we need. So for example, if we are at the chip like this, we can, that has the lettering upside down, we can rotate the camera 180 degrees and actually have all the lettering and everything the right way up. And as we move, we can see the chip number and any markings that we are interested in. Okay, so let's start by removing the electrical tape that is holding this in place. And you could see that using the right battery size, this will actually slide in. If I align it correctly, will slide in and close. Unfortunately, I don't have the right cells. I'm only having the LR44 at the moment, and this one uses pieces that are shorter, so I'll try and solder maybe wires directly that will come out of that board. And I don't know, should we try and 3D print an enclosure for that so it matches and holds nicely? Let's try and do that. Yeah, so I thought about making a 3D printed case for this, but I don't feel confident, at least not with my skill level of 3D design, because it needs some complex geometry. I was hoping to have it slide in the groove that it has for the cover, but that will be only 0.4 millimeters thick. And if I don't print it upright, then I don't think it's gonna fit because of all the supports and everything. So what I'm gonna do instead is just budge it up. I'll solder wires to the contact, so we have the minus there on the end and the plus here on the side. These two are just bridging the two batteries to make it so they are all connected in series. And after that, I'm gonna solder the wires here on the board. I'm gonna secure the battery at the end here with electrical tape, same as I had the cover before that, and I'm gonna secure the PCB on top so that I could charge it here from the side when there is need to. Okay, so that's not really working the way I expected it to work. I couldn't get the solder to connect, and I'm just melting the plastic, so I guess I'm gonna need to open this up and get access to the wires that go to the LED. Okay, so here it is inside, and this is the mechanism that moves this piece up and down, and this one moves this piece also up and down to adjust the focus. So let's try and remove all of this. And let's try and solder directly to here and to here. Okay, so this one is the positive. And I'm gonna try and press it so it connects with the switch, which I think it does. So we're gonna have that coming from there, and I'm gonna solder the negative here directly at the LED. Okay, and let's confirm that it lights up. And it does. Now let's put it back together. Okay, here it is ready, but as you can see on screen, one of the issues that we currently have is that the LED is probably too bright because the battery is fully charged. So we're at 4 volts and this is a 3 volt LED. So I'm gonna add a resistor in series to limit the current to something smaller. Okay, so here it is with the 100 ohm resistor, and if we go at any one of the chips, we could easily see and figure out what the number is. So we have Nikos P0903BD, and that's much easier to see with the camera instead of me leaning over the microscope. And if we go at any of the small components and try to focus, so we have A2SH8. So A2SH8 or B, whatever that is. If we go to some of the solder components or white components, the LED is probably just a bit too bright still. So I might increase the resistor value just a tiny bit, but I'm gonna use it for now, see how it behaves, see how it works, and I can change the resistor at any given time if I ever want to. But I think that for the chips, so the SMD chips, I think it's very much usable, and I'm really happy with the result. And here I have a PCB ruler, and we're looking at 0.3 hole at the maximum magnification. And you could see, let me try if I can maybe focus a bit. Now that's it. We could see the solder mask as well as the hole and the plated through hole. So this is 20. Okay, it's a bit difficult to navigate at such a small scale, especially because I have the camera rotated, and this is like this, and this is at the minimum magnification level, so 0.3 and all the way up to, okay, what's the first one? 3.25 millimeters. That's out. So we have a viewing area of about 2.3 millimeters, which I think just for some handheld microscope is quite okay and quite usable. And here's the finished product. I'm quite happy with the results that I managed to get, especially with the improved battery situation, because I can now charge this and have it ready whenever I need to, and I don't need to worry about having the right coin cells. An additional benefit with adding the camera on top is that I can now show you parts of the chip numbers that I'm looking at, and I can show you details of the PCB in any project that I need to. Let me know what you think. I know it doesn't look the best because we didn't manage to figure out how to make a 3D case, 3D cover for this, but I think it's still quite usable. If you liked it, then be sure to leave a like down below. Let me know down in the video comments if you have any questions. Make sure to subscribe, and I will see you all in the next one. Cheers!